Hello, in this video we will be covering lesson 3.2 of implicit differentiation. So what's the difference between an explicit equation versus an implicit equation? An explicit equation is an equation that's only in terms of one variable. So in this example, we can say that y equals x plus 16. We see here that y is in terms of x, and it's only in terms of one variable, which in this case is x. An implicit equation has multiple variables that are not expressed solely like in this equation. So for this example, we can have x squared plus y squared equals 16. Now this is just an equation for a circle, and you see here that on one side we have two variables, an x and y. In comparison to this equation, we have y and x on separate sides. So in this video we will be covering how to differentiate implicit equations and how to go about that. Okay, so here we have in terms of x and in terms of y. Now, we all know that if we take a derivative of just x, we get 1. But why is that? It's because we've been skipping a step that is basically saying this is technically the same as dx over dx, which is just equal to 1, since dx over dx just cancels out and becomes 1. For this example, this is different because we're taking a derivative of y, not x. So we won't get a dx over dx. We will essentially be getting a dy over dx. So it would be 1, but essentially that 1, this y, goes on top of here and becomes a dy over dx. Now for the bottom one, the derivative of x squared, we all know would be 2x. But we're skipping this part where we also include dx over dx, which, as we've known from the first equation, that just cancels out and just gives us 2x. For this one, we're going to be essentially doing the same thing. So whenever we take the derivative of y, we essentially have to add a dy over dx. Now in this equation, the derivative of y squared is just going to be 2y. But since we took the derivative of a y variable, we will have to add a dy dx. For this problem, the derivative of e to the 5x is just e to the 5x times 5 because of chain rule. And essentially, we're also including dx over dx. Cancels out, and we're just left with this. If we do the same for here, we're going to do the same thing that we've been doing for these two. So we get e to the 5y, and then since we're doing chain rule, we times that by 5, but we also have to include a dy over dx because we took the derivative of 5. So right here we have a problem, and we're basically trying to find dy over dx for this equation. Now we've noticed that this is an implicit equation. So to take the derivative of this implicit equation, each time we take the derivative of y, we're going to involve a dy over dx. As we did in the last problems where we took the derivative of y, we got dy over dx. So that's what we're going to be doing. To make this a little bit easier, I'm going to show you how to kind of remember to do that. So we do d over dx bracket y squared minus 5x cubed bracket equals d over dx bracket 3y bracket. This will help you remember that you're doing implicit differentiation It helped me kind of, organize myself. But essentially, since we're taking the derivative of y squared, this is just 2y. But since we're taking the derivative of a y, we have to times that by dy over dx. For this part, we're taking the derivative of negative 5x cubed. This will just be 15x squared, and it's just 15x squared, because if we were to add the dx over dx, it would just cancel out. So we don't really have to include that, since we're only including dy over dx if we're taking the derivative of y. So this would just be negative 15x squared. It's pretty simple. Then we equal it and we do the derivative of 3y. Now we're noticing there's a y here. So we should keep in mind that we're gonna have to multiply whatever the derivative of this is with dy over dx. So the derivative of 3y is just 3, but since we took the derivative of a y variable, we add a dy over dx. Now, to separate all these terms, we want to have all the dy's on one side of the equation, and then the x variables on the other. So it doesn't really matter which side you put it on, but I'm just gonna minus the 3 dy over dx to this side, and then add the 15x squared to this side. So I'm gonna do that. So 2y dy over dx minus 3 dy dx equal to 15x squared, since we're since we have to add the 15x squared to this side in order to move it to this side. Okay, so we're left with 2y dy dx minus 3 dy dx equals 15x squared. Now, this we can just kind of I guess, factor out the common variable in this case, and that's just dy over dx. So we get dy over dx, and then we can do parentheses, so we get 2y minus 3 equal to 15x squared. Now, since we have to find dy over dx, we have to essentially divide all of this by 2y minus 3, 2y minus 3, and this is essentially what we get. So we essentially get that dy over dx is equal to 15x squared divided by 2y minus 3. This is our answer. That is our answer for this problem, since it's asking us to find the derivative, or dy over dx, of this implicit equation. For this problem, we have an implicit equation of y cubed minus 2x equal to x to the 4th power plus 2y. How are we going to find dy over dx for this implicit equation? We can follow what I've done throughout the first problem that I covered, which is just to highlight that we're taking the derivative of each term, so we don't forget to add our dy over dx if we're taking the derivative of y. So right now I'm just doing the first process. Okay, now that we've done this, now we can take the derivative. So the derivative of y cubed is just 3y squared. But since we took the derivative of a y variable, we have to add our dy over dx. We don't have to do this for an x variable, as we've known that the derivative of an x variable term would just give us dx over dx, which essentially cancels out and gives us 1. So we can just say that the derivative of negative 2x is just negative 2. Now this is equal to this part of the implicit equation. So the derivative of x to the 4th power would just be 4x cubed. We don't have to include a dx over dx because it just becomes a 1. and it just leaves us with 4x cubed. Now if we find the derivative of 2y, we know that that's just 2. But since we took the derivative of a y term, we have to add our dy over dx. The second step to solving an implicit equation, or to taking a derivative of an implicit equation, we have to separate our terms. In this case, our dy over dx's on one side and our x variable onlys or constants on the other. So for here, I'm going to want to add the 2 to this side and minus the 2 dy dx on the other. So I'm going to do that. 3y squared dy dx minus 2 dy dx is equal to 4x cubed plus 2. So now that we've separated our like terms to their specific sides, we can just factor out a dy over dx Once we have factored everything out, we notice that we can find dy over dx by dividing by the 3y minus squared. Now if we divide by this whole term, we have to do it to the other side. So we're going to divide that by 3y squared minus 2. So we're left with, if we divided this by itself, we just get dy over dx, and we get that it's equal to 4x cubed plus 2 over 3y squared minus 2. So this is our answer to finding what dy over dx is equal to.